After a baseball is hit, so that it travels straight upward after being struck by the bat. A fan observes that it takes 3 seconds for the ball to reach its maximum height. Find the ball's initial velocity and the height as it reaches. So, I encourage you guys to pause this video and to give this problem a shot. So, before we start solving this, and yes, we can solve this very easily, but more importantly, I want you guys to be able to understand the motion craft, the equations, how to use the mathematics as a tool to set up the equations and to read it off the math, which is more important than anything else. So the important thing is that you understand what you're doing so you're not blindly plugging and juggling, folks. That's the whole purpose of these videos. It's not to teach you how to get to the answer, but to show you why or why we do the things we do. So you can better understand the material. Alright, so let's graph the motion. So the motion is going to look like this. Something like that. It's gonna be a parabola, and we're gonna let the ground be zero where the ball strikes the baseball, even though it's actually a little farther than zero. We usually mark it at the center of mass, but whatever. We're not gonna look to pay attention too much of it. But notice that the ball. Think of the ball as ignoring the horizontal motion. When it goes up in the air, the vertical distance is going to be where the y-axis is going to be. In fact, let me do that. Kind of put that in the x-axis. Let me change that. That's going to be the y-axis. And g is going to be 9.8 meters per second square, because that's going to be the acceleration. And the ball is going to go up in the air in some vertical height. Of course, it's going to have some horizontal motion, but we're going to ignore that. And it's going to go up to its maximum height. And then it's going to slow down, and then it's going to pick up speed as it goes down. So, in other words, the acceleration of the ball is going to be 9.8 meters per second square. And we're going to put negative as to emphasize downward as that direction. So the motion already, we can set this up as saying y equals the horizontal position, which is 0, the initial velocity, which is probably going to have some initial velocity. A baseball bat is hit so that it travels straight upward after being struck by the bat. I'm not sure we're going to put it at some initial velocity. I guess we're going to ignore that. Oh, actually, you would need it because it's going to go up. Yeah, you definitely need it. My bad. So, yeah, so this is going to basically be the equation. So, some initial velocity times the time minus gt squared over 2. Oh, yeah, and that's what it's asking for, too. I haven't really read the question, but yeah, that's what it's asking. The ball's initial velocity. When you take the derivative to respect to time, you get your new equation, which is going to be the final velocity, some initial velocity, minus gt. These are your basic two equations that we're going to observe. But the velocity is the direction that this ball is traveling. So think about that, folks. The direction of the position that's changing when the change of t is going in that direction, that's when it's going to travel up. So the direction of the change of y, whether it be positive or negative, is going to be the velocity. It's going to be the final velocity. The initial velocity is some velocity right here. So this is really more of mathematics than anything. So really, after you set everything set up, let's let the final velocity be 0 meters per second. We're going to find the time it takes. That specific t0, where the velocity is 0. So now all we have to do is move the velocity on the left side divided by g, and that's going to be the time t0. So part A, the v0. Oh wait, it's well, regardless, v0 is going to be g of t. So that's going to be 9.8 meters per second square. times the time it takes, which I guess it does give us the time, 3 seconds. So we're gonna, so that's gonna be 30 minus, that would be 30 minus 6, which is 20. It looks like it's, well, I'm just gonna put it in the calculator, 29.4. So now we just solve for the initial velocity being 29.4 meters per second. So once you solve for the final velocity, you're going to plug that final velocity into that equation. So now you have some new equation, which is going to be gt squared minus gt squared over 2. Or in this case, you're going to have the equation 2 over 2. 2 minus 1 is going to be gt squared over 2. There's your equation for y being the position of the maximum height. And once you put this in the calculator, folks, y is going to be specifically gt squared over 2, which is going to be 44.10 meters. So that's the time. So at 3 seconds, so the final, the position here is 44.1 meters. And that's all they're asking. Notice this is really just a plug and check problem, and it's pretty straightforward. But make sure you read the mathematics and are not just blindly doing, because I just wanted to take an opportunity and to maybe give you guys like a lesson of like the velocity in the position, because I really want you guys to study this if you're watching my videos. Otherwise, you're gonna see me go way too fast, and then you'll probably get confused. But and forgive me, but that's the way I am. But more importantly, folks, I want you guys to focus on understanding